Let's go ahead and look at this problem about subtracting these two rational expressions. First thing you want to do is look at the denominators, because when you subtract or add fractions you need to have a common denominator. And obviously we don't have that right now. So let's go ahead and factor the denominator on the left here, x squared plus 5x plus 6. You can find that that factors into x plus 2 times x plus 3. In the second fraction, we do not have to do any factoring, so we just recopy it. Now if you look at the denominators, you can see they both already have x plus 2 as a factor, but this one has x plus 3 and this one does not. So to get the common denominator, you want to incorporate x plus 3 into the second fraction. So I'm going to bundle this into parentheses, and then I'm going to times by x plus 3 on the bottom to get that. But then, of course, to balance it, you have to multiply by the same thing on the top. And it helps to put parentheses in around the original expressions just to remind yourself that these are binomials, that x and the plus 2 go together. Now the next step would be to simplify the top half of this second fraction. And I'm just going to hold off on this one for now. I'm just going to recopy it. So I have x squared minus 10 over x plus 2, x plus 3. And then for the second one, I'm going to FOIL out the top. I'm going to multiply it out. So x squared plus 3x minus 4x minus 12. And then on the bottom, I'm going to leave it factored. We tend to keep the denominators of rational expressions factored at all times. The reason that I had to multiply out the numerator, though, was because my goal is to subtract, and eventually when you subtract two fractions, you want to take the first numerator and subtract from it the second one. So it needs it to be expanded in order to be able to do that. But here's the part where I think is probably the most likely place for a person to make an error. You are subtracting this whole expression from this one, and so to make that maybe more clear, you may want to put parentheses around this and remind yourself that this subtract sign does apply to all of the terms in the second fraction. And so if you were to say maybe rewrite that, at least as you're learning the process, it's a good idea to rewrite it. What we're really talking about is x squared minus 10, and then I'm distributing this pink minus sign now. So it'll be minus x squared minus 3x plus 4x and plus 12, because when you have a negative, it distributes. So I have combined them together. I can now write them as a single fraction over x plus 2, x plus 3, but only because I distributed that minus sign onto all of the terms in the second one. So then finally, when I combine like terms on the top of the fraction, well, there's a couple that cancel. X squared and minus x squared are gone. For the x's, I have a minus 3x and a plus 3x, so that would be just, minus 3x and plus 4x. That would be plus 1x. And then I have a minus 10 and a plus 12, so that would become plus 2 over x plus 2, x plus 3. And now maybe you can see why keeping the denominator factored is a good idea, because I have some canceling that can occur with the top and the bottom. So with that in mind, since the x plus 2's cancel, I'm left with x plus 3, but it's on the bottom of the fraction. And since there's nothing else left on the top, you have to go, well, is it a 0 up there? Is it a 1? But it's x plus 2 times 1. So if you do cancel everything from one half of the fraction, you can still think of it as it having a 1 in that spot. And since you have to have something in the numerator, you put a 1 there. So that will be your final answer, 1 over x plus 3. Hope that helps.
Made with Doodlecast Pro.